Yes. Okay. So, good afternoon. I extend a very warm welcome to all of for the inaugural session of our online lecture series, actually organized by under the aegis of our university, Maulana Abul Kalam Azad University of Technology. Today, the marks of the formal inauguration lecture series, which has been conceptualized to the foster academic engagement, knowledge sharing, and meaningful interaction between the academia and the professionals. I would also like to inform you that the recorded version of all the lectures in this lecture series will be uploaded in our official YouTube channel, Online MAKAUT. So I request all of you to kindly subscribe to the channel so that in future you know about the initiative that we we take. Okay. So I would like to mention that I am actually serving as a moderator of this lecture series, and it is an honor for me to coordinate and moderate this academic initiative. The actually till now the lot of participants are waiting. Just 1 minute, I allowed all of them. Just 1 minute. Yes. Now, I request our distinguished speaker for today's session, Ayon Hazra. Say Ayon Hazra. Before that, I just tell you about Ayon. I have already uploaded the details of Ayon Hazra in that dashboard. Just I tell you about our speaker. Ayon Hazra is a deep tech entrepreneur having the build of the blockchain fast startup Borlag Web Services, BWS. He serves as a co-founder of the Nube Native Solutions with over 20 years of experience in business and technology consulting. His expertise spans frontier technologies like blockchain and AI, supply chain optimization, and large-scale digital rollouts. Prior to his current venture, he had held consulting roles at global organizations including the Ericsson, Oracle, and Cognizant. Ayon is an active contributor to industry development, serving as a member on the CII West Bengal State Council and the CII Eastern Region Startup Subcommittee. He has also contributed to the National Skilling Initiative as part of the Blockchain National Occupational Standard (NOS) work group under the Ministry of the Skill Development Entrepreneurship. Before start the session, I just request all of you kindly mute your microphone and also switch off your cameras. And at the end of this lecture, there will be a question and answer session. So if you want to ask the question, please raise your hands and I will select one by one accordingly. So now I request Ayon to start the lecture. Ayon, please.
Yeah, sure. Let me share my screen as well. Just a second. Is the screen visible?
Yes, it is visible.
Yeah. Okay. Thanks to all of you for joining in. And I've planned this session. It's pretty long. I mean, it's a longer session. We are used to giving. I mean, we're not used to taking classes or sessions much. But what I've done is maybe I've broken it up into 3 segments. One is the first. So we have 45 minutes each. The first would be a 45-minute session where I'll talk about the basics of blockchain as a technology, what kind of enterprise applications are happening, I mean, general applications. Then probably the second half is where we can take a break and then we can have a second half where I'll talk about how blockchain and security is working hand in hand. It's like very pertinent today. So that would be a session more on blockchain and security. And third would be the real world applications where we can also talk about certain live applications, and I'll give a demo on that. So that would be a session where I'll share some application I'll go into the application, show you how a blockchain works, how one of the recent rollouts have happened, and how it's working. It's a government application, so we'll show you some real world applications as well. So that's how I've planned it out. For the first session, as I said, like we'll start off with the basics of blockchain. After about 30 minutes, I'll give certain, I'll make it more interactive. So I'll pause at certain logical stages and then probably have a interactive session. Uh, if you have any questions, just put it on the chat and then we can discuss during those breaks. So, yeah, so I'll just start off with certain important things that we talk about in the industry about blockchain. Whenever we start about blockchain, the first thing that comes to mind for at least today, earlier it was just cryptos, but today it is about crypto trading. I mean, that's the first thing that comes to mind, right? But blockchain as a technology is just beyond crypto payments. Payments is the most well-known application at enterprise grade that is going on. But as a technology also, blockchain is being used in multiple industries. So what we'll cover in this session is how, first of all, very basics of certain things about blockchain. I am not, what I understand about the group here is most of you are research scholars or already come from that background. So you have, it's a technical group here. So I'll talk about the certain components of how a blockchain works, and this will be more technical in this session. And if you have questions, we'll clarify those. So let's go to the top trends of blockchain applications. If I look ahead 2026 and ahead. Today, when we are looking at blockchain, we're talking about more about real world assets. That's one of the RWA is one of the biggest adoption that is happening on the blockchain side. More today, the GCC countries, the Middle East has already taken a step ahead where RWA is being actually practiced, and there are a lot of applications being implemented. So asset tokenization, that thing is going mainstream. So that's one. Second is more on the institutional side. Earlier adoption was slow, but now because of better regulations and regulations becoming more mature, there is institutional adoption of blockchain. Finally, also on this, like I was talking about payments. Now, one of the very important trends that we are seeing in blockchain today is the rise of stable coins. There was a coin called Tether, which was it was pegged on dollar, right? It's still there. So stablecoin took some time to find its sweet spot. Today, cross-border payments are being pegged through stablecoins. So the entire intermediary infrastructure is being handled through these stablecoins. It's faster payments, and then we'll talk about a few applications there as well. The other area where it has been going for long and still the technology is evolving is more on the cross-chain interoperability. If something is not clear, I will make these things clear, but I'm just talking about applications. So cross-chain, what is cross-chain interoperability? We heard about Bitcoin, Ethereum, Polkadot, a whole lot of blockchains, right? But do these blockchains talk to each other? Whenever we talk about cross-chain interoperability is where things have not evolved much in the earlier years. Now it is evolving, and we are having the concept of relay chains in Polkadot where multiple chains can talk to each other. Then we have something called layer 2 scaling. You must have heard about a company called Polygon. It's an Indian company, I mean, Indian founders, but then they became really big. They're no more in India. They've gone out and they're now more in Singapore and Dubai, their incorporation and all. But Polygon, that's a typical layer 2 scaling company which has made headlines, and they just go growing stronger. They are on Ethereum. They're a layer 2 on Ethereum. They bring in that speed. So there is a settlement happening in the layer 2 and then happening on the layer 1, which is solving a lot of problems that Ethereum had. So Polygon is one example, and there are multiple such examples. Next is AI plus blockchain. Here, I'll just take a moment here. It's not just applications. With AI, with the rise of AI, what is happening is blockchain, if you see, most of the discussions, whenever we used to have blockchain discussions, people used to say, okay, if it is on blockchain, I trust the data. It is trusting. So there's a fine line of difference there. Whenever we are saying trusting data and trusting that fact, there are two completely different things. If I have put in a certain payment has happened from A to B as $10, so that $10, when it was put, it will become immutable. It will not change over time. I can trust that $10, but is the fact correct that the $10 really went from, if it was not a crypto payment, it's just a fact, that really went from A to B? So whenever we are talking about fact is where all these pattern matching, predictability, intelligence comes in with AI. So there are two things these two technologies serve, and both together can be a very powerful combination. So AI plus blockchain together is solving a lot of problems on supply chain traceability, or the trust, or the digital twin projects. And digital twin is not just, there's a multiple technologies come together and solve that problem. Then comes enterprise and blockchain. The government blockchain builds. And wherever we are sitting today, West Bengal has its own blockchain today, which is Bengal blockchain. I'll give a demo on that in the last session. So governments in India, outside, everywhere have adopted blockchain in a big way. And that was probably the best use case of blockchain outside payments and Bitcoin and all, I would say, because it brings in a lot of transparency in governance and creates that trust layer. Then I'll talk about security and how blockchain is playing a role in security. And then finally, how blockchain infrastructure, it's from a technology, it has now become an infrastructure. So it's becoming invisible. It's becoming commodity now. So these are kind of trends that we will see going forward. And now coming to certain concepts. So when we talk about blockchain, there are a few things we have to clarify here. First is, see, blockchain, there are three keywords I'll use. One is trust, integrity, which is part of the trust. And the third thing is ownership. These are the three keywords whenever we talk about blockchain. Ownership is a very, very big keyword, that, or a problem that we are solving from centralized to decentralized world. So what was centralized? If I see the evolution, and I'll take that in this second session as well, because there are things that would overlap in the second session. So whenever we're talking about centralized, if you look at the earlier systems, there was a single point of control. So we used to have banks, or we trusted banks on our data, on our money that we keep in banks. So the single point of control, that's centralized. The problem with single authority is it's a single point of failure as well. From there, we went to the ownership was still centralized. Then we went to distributed, or we had multiple copies. Systems became more resilient. So you have multiple copies of it, but still a single ownership. And there were hybrid models where there were multiple owners, but still a single copy. But if I change a copy, the master copy, when it replicates, it also changes the others. Then came certain systems which were more decentralized. There was no single point of control. So that's when the rise of decentralized systems, where there is no single point of control, the trust shifted from you trusting on a person to building the trust in programmatically in the system itself. So if this happens, or if, let's say, we achieve 50% reorder point level, it will automatically procure this product at this price or at this price range. So this is something that you're putting in programmatically, and you're not letting somebody decide there or have any point of decision making is more programmatic. So that was one part. The other part was, whenever we are doing any transaction, there are multiple decentralized parties validating that transaction. So we went from centralized distributed to decentralized systems, and the ownership became from centralized to hybrid, or to distributed to decentralized systems. So that's the evolution that took place. And if I look back at the industry, if all of you remember, there was a company called Napster. It brought in, like, I remember in my earlier days, I was young, and then we used to have movies from Napster, music from Napster. Music we had to buy, but if you had got Napster, you could listen to those music, right? It was more decentralized. So that's where sharing of files started. So I had a file on Napster. I can let my friends listen to that music. There was a huge network of people sharing information between each other. So that's where the peer-to-peer system started. So P2P took birth from, and at scale, from Napster. Till Napster founder got charged, and then it got shut down because of file sharing and piracy and all. But that was the first time when we saw peer-to-peer systems having that power to share information, and we had participation from a huge, participation globally. There were no central authority managing Napster, right? So everybody had their own files they could share with each other, and people could listen to music. So this was a very key moment in the industry when we had slowly that centralization was going out. Now came now with time, we saw, and I'll talk about the inception in the next slide. But what is a DLT? Again, commonly used terms which are used in place of the other. We use DLT, we use blockchain, we use a private blockchain. There's nothing called private blockchain. A private blockchain means it's a private network. So blockchain is meant to be either permissioned or public. And what is a distributed ledger technology, DLT? It's, like I said, we started off with P2P in the last slide. So it's a form of a technology where we keep ledgers and the ownership is distributed. So there are multiple owners of the information being shared with multiple people, and it's lying in the Napster servers in various places. So that's what DLT is. It records and shares data across multiple data stores or ledgers, where each have the exact same data record. So the ledgers are copied, and then from those nodes, you are reading the information. But blockchain is a type of DLT. Blockchain isn't DLT. DLT, there are other technologies or other forms of data stores uh, for a DLT. In blockchain, what it does, it stores in a Merkle tree structure. Not going to Merkle tree right now, but it stores in a certain way. So there is a certain data structure followed in blockchain, and there is no centralized ownership. The records, when you write the record, it is validated by the participants or who participate in the consensus process. So there is something called consensus. So whenever I'm writing data to a database, we just write the data, right? Whoever has write permissions permissions can write the data or delete the data. Here it's an append-only database. Just think of it in that way. It stores the record in a block, not in a simple table. It stores the record in a block. So multiple transactions are packed in a block. The block is added to a chain of blocks, and it keeps on, it checks the previous block because it keeps a record of the previous block. So it continues that chain. So if you change any one of the records in the middle of the chain, it breaks and it immediately does not allow that change to happen. The validators would not allow that change to happen. So blockchain is a type of DLT which stores data in certain blocks. It's again a decentralized technology, whether it is permissioned or a permissionless blockchain, a public blockchain. That is again another definition. I'll come to that. So essentially, blockchain is a tool for achieving integrity in distributed software systems. Again, coming back to those three words: ownership, trust, integrity. And how do we maintain that immutability is what I just spoke about. Like if you change any part of it's stored in such a way that if you change any part of the data, it will break the chain. So that is why you cannot break the chain unless there is a 51% attack where all the ledgers have to change the data at this, all the ledgers in the nodes where it is stored. Every node data has to be changed, and the kind of energy that is required to do that change is humongous and practically probably not possible unless quantum and all these things come out. So that's why there is a strong discussion going on that we can theoretically break a blockchain's integrity with quantum computing. Now, what has been the adoption like, or I think, where is the inception slide? Just give me one moment. This has been hidden, sorry. Yeah. So if I look at the inception of blockchains, right? First paper was around, so there was two scientists, Scott and Hibber, in 1991. That was the first paper on blockchain. Around then we had Merkle tree structure, which is the concept of Merkle tree to join multiple documents in a single block. We had something called consensus mechanism, like a proof of work. So the initial consensus mechanism for Bitcoins even is proof of work. So 51% of the network has to agree upon or validate any transaction. It's a very crude way of explaining proof of work. Then the reusable proof of work paper was given by Half in a RPOW, and then that was around 2004, and 2009 was the first introduction is 2008, and the first Bitcoin mining and transaction happened in 2009. And just imagine whoever had At that point in time, we use, if somebody had access to that network or got bitcoins in their wallet, they used to get a lot of, because less validators were there. So the the incentive of mining a bitcoin, and I'll come to what mining is, incentive of mining a bitcoin was very high. So if you are able to mine successfully, you used to get like 5 bitcoins, 10 bitcoins, and these kind of things. They're massively high. Just imagine those 10 bitcoins, how much would it cost today? So with the growth of Bitcoin, the incentives reduced, because that's how the network is designed. So it will reduce, the complexity would become very hard for the computation to happen. So the incentive is reduced. Today it's very less. I mean, it's hardly anybody would get to mine. It's very difficult to mine a Bitcoin today, unless you have huge systems. And the adoption happened. Initially was cryptocurrency, then Ethereum came. So after Bitcoin did not have computational ability, or not computation, rather did not have business logic inside it. So Ethereum had something called smart contracts or business logic. It's not a legal contract or anything. Smart contract is essentially basically a business logic. It's a small piece of code where you can write business logic. So that's when 2014 Ethereum got launched, and then it evolved. Then at around 2014 and 15, Hyperledger also Hyperledger Fabric was one of the projects under Linux Foundation. So whenever people say Hyperledger is not a blockchain. In fact, Hyperledger Fabric is also not a blockchain. It's a DLT, because it's a different form of data storage, and it's not decentralized. It's actually centralized to a certain extent. Hyperledger Fabric. Then blockchain goes global with banks like JP Morgan and all these major banks adopting it. Then US regulators approved Bitcoin as a mainstream investment around 2017. And then we all know how things have happened. Then the bans came in, the sanctions came in, and how it has evolved over time. Now, these are the characteristics of any blockchain. See, this session is only about certain concepts of blockchain. It may sound very boring, but these are things I need to talk about so that I can start the next session. The next session is more on applications, and I can talk more about applications. So here, when I talk about blockchain characteristics, so when we say immutable, what does immutable mean? Immutable means it is unalterable. So why is it unalterable? This was one of the explanations given of blockchain. It was a YouTube video given to a child. So let's say we are, if I tell you that T20 World Cup, Cricket World Cup, Men's World Cup is happening in South Africa, would you agree to that? You would never agree to that, because that's public information. So if I now draw an analogy, it's in India, so it's public information which I cannot tamper, because it's very difficult to influence so many people at the same time and change the location from India to South Africa. It's the same concept how blockchain works. When you have public information in so many, when you have information in so many nodes, and if I have to change that information in so many nodes at the same point in time, it's very difficult. And that's why blockchain information is immutable. Why is it append only? The structure says it can only append. It cannot update information like in a database. It is ordered in a chain. It is time-stamped. So even that makes it even more difficult to break. It's time-stamped. It's open and transparent. It's only in case of public blockchains where anybody can join a Ethereum network, anybody can join a blockchain, a Bitcoin network. But if I tell you, can you join the Bengal blockchain network, which is a permission network, you can't. Because only permissioned or KYC'd, or it's not anonymous, it's pseudonymous. So in case of permission networks, we know which are the participants in the network. So that's the difference. Finally, it's secure and eventually consistent. Why is it said eventually consistent? Because not going into the mathematical side of how blockchain transactions are happening, but this essentially what this means is we have something called uncle blocks. So if a rogue participant have been creating rogue blocks, or rogue blocks means which are not validated. So you start extending the ledger, but it does not get those blocks do not get added to the main ledger. So eventually the network makes it consistent. There is something called finality of blocks. Again, that's a concept, but essentially whenever a block is finalized, what it means is a block is validated and then finalized to add to the blockchain. So there is transaction, multiple transaction in a particular time period is consolidated into one block. Then that block is validated by the network. Somebody mines it, and the block is added to the blockchain. So it's always eventually consistent. So we use certain concepts like cryptography, digital signatures to prove identity, ownership. Now coming back to from immutability, integrity, now coming back to ownership. Whenever we are writing any data to blockchain, you write it with your, you sign it with a digital signature signs it. Now, an identity of any person on a blockchain is a wallet. So that's why people say that it's anonymous. So your existence in Bitcoin or your existence in Ethereum is defined by a public key, which is a cryptographic public key. So we all know about public key, private key cryptography, right? Encryption. So I am known to the world through my public key, and that is the wallet address. That's my identity. So I sign it. I need to sign it with my, if I'm sending a transaction or I'm digitally signing a transaction, I will only know my private key. So my wallet has the private key where I sign it with my private key, but it gets digitally signed and gets visible to the other people through my public key. So since I know that this is the public key for this person, so I know this is the person who has sent me that transaction or has signed the transaction. A blockchain is time-stamped. I've already spoken about it. Hashing. Okay, there are multiple hash functions. I'll share these decks with all of you. I mean, if you want, you can go to these links and you can. So essentially, it is asymmetric cryptography, like public key, private key. So there is a key to sign it. There's a key to verify who owns it. So there is signing a transaction, verifying a transaction. And hash functions, there are various hash functions used, like SHA-256, SHA-512, SHA-512. These are all one-way hashing techniques. So what is a one-way hashing? If I have a data and I hash the data, the resultant that I get is a, okay. So maybe this is a time I'll share one of the transactions on a blockchain. Just give me one moment. So if you can see, this is explorer of a blockchain where you can see all the transactions that are happening on this blockchain, right? So if I go to this block, so this is a block which has so many transactions that are packed inside. So these many transactions have happened in this block. Okay, these are the transactions which are packed in a block. So about 40 transactions have been packed into one block. It has been timestamped on this date. It has been hashed. So this block has been hashed. This is the block hash. So why is that block hash required? Because the next block has to, we've all learned, if we've all come from technical backgrounds, so we've all learned linked lists, right? So it's kind of a linked list. Blockchain is also kind of a linked list structure. So it will connect to this block hash. So and this is the parent hash. So what does parent hash mean? So this is connecting to my earlier block. So this block is connecting to my earlier block. And then if I go into any of these transactions, I see who had signed this. So there is a transaction hash as well. Whose digital signature went in? What are the parameters that has gone in? And what is my public address or public key? Sorry. So this is my wallet address. This is my wallet address. This is the signature, digital signature of this wallet address. So these are things that I'm just showing you from the system itself. And what is it? It's a transaction where it had created an identity. I'm not going into this. This requires further understanding of which use case we are talking about. I'll talk about the use case in the last session. Okay, coming back. So these hash functions are used and you cannot go back. So why these hash functions are used? One-way hashing is used. So you cannot, so it's like apple and apple juice. So if you make an apple juice, from the apple juice, you cannot get back the apple. It's a one-way hashing function. So once you hash it, you cannot get back the original data from it. What you can do is you can check. If I tell you, okay, this is the hash that was kept on the chain and this is the original data. If I give you that data and if you want to check, okay, is this the same data that has been kept on the chain? It will hash and check that whether it's the same hash or not. And then it can tell you, okay, this is the original information that was hashed. If it was changed, even if a minor change has happened, the hash will not match. So the same data will hash every time with the same. If you use the same hash function, then you get the same hash. That's how you verify on various things on blockchain. Finally, coming to smart contracts. As I said, with Ethereum, we started off with something called business applications or business logic. You can put in small business logic on blockchain. Not just transfer. Bitcoin used to transfer tokens from one wallet to another wallet. That's why payment used to happen on Bitcoin. So Bitcoin's best use case is payments. Then came smart contracts with Ethereum where you can write some logic. So these are self-executing programs stored on the blockchain network. Even these programs are immutable. That's why blockchain programs, see, it's not just the data that you keep on the blockchain. Everything on blockchain is immutable. Even the programs that you deploy as a smart contract is immutable. So permanently, it will always act in the way the smart contract has been written. It will never have exceptions. If I have written a if-then-else statement on a smart contract, it will always behave the same way. That's why you can programmatically transfer the trust from an individual to a decentralized form where the system is taking care of executing certain things. So you cannot tamper even smart contracts. That's why the trust there was a major shift, trust getting shifted from individuals back to the system itself. Now, what are programming languages that are used typically in various blockchains are Rust, ink contracts used in Polkadot, Solidity, Go. So these are generally technologies that are required to write these smart contracts. There are two sides to blockchain. And now coming to more academic stuff, India has initially we used to write a lot of dApps, but there was very little work happening in India. It was mostly happening in Russia, Canada, and these places, and Berlin. These were the hubs of blockchain. So Vitalik was based out of Toronto. Berlin had a lot of Polkadot people. One of the Ethereum co-founders was based out of there. So these places, it was work at the protocol level. These different blockchains have different protocols. Even Polkadot is built differently. Ethereum is built differently. All of them have their own pros and cons. But at the protocol level, there was very less work happening. But right now, if you see, there are a lot of people working from India remotely for these companies, as well as they are working even in abroad. So protocol level work is still, it holds a lot of, from a incentive or from people who are key to blockchain. Those are the people who call the shots, you can say. And they are regarded very highly in the industry because they are the ones who can identify also the vulnerabilities in blockchain. And we've heard a lot of, that's when I'll talk about the security aspect and how things are getting stolen from wallets. So that brings me to wallets in blockchain. So wallets hold your private keys, but it also, that's how you sign the transactions. But your public key address is known to, it's a pseudonymous thing which is known to the outside world. So they know that it is coming from these wallets. Now, there are various types of wallets. Earlier, used to have something called a ledger wallet. Ledger wallet is a hardware wallet. So many people used to lose wallets. So then Ledger, there was a company called Ledger. They used to have, they still have hardware wallets. So you can keep, it's like a pen drive, and you can keep the wallet address on the pen drive. So once you put in that, you keep all your, the tokens that you have. It can be on Bitcoin, it can be on Ethereum. You can keep it on a hardware wallet. There are offline storage wallet options, which are called cold wallets. Then there is something called custodial and non-custodial wallets. I've not written it down here, I just missed that. But essentially, there are two types of wallets. What's a custodial and a non-custodial wallet? Whenever you are transacting crypto on any trading exchange, whether that is Kraken or Binance or all these different exchanges. In India, we have these CoinDCX and all. They keep your private keys. That's called custodial. If you keep earlier, when there was no, there was less of exchanges, and we needed crypto to do certain, projects on blockchain, on Ethereum and all. The developers would essentially have non-custodial wallets where I would control the wallets, the private keys and all are known to me. But the risk of that in an exchange is if you somehow lose your private keys, if you forget, it's like losing your, there is no way to recover that. So that is why on the safer side, we have to trust the exchange to keep our wallet private keys with them. So that's a custodial wallet. What is the role of fees within the blockchain? So why would people give their compute? So essentially what is happening inside the blockchain? You're all connecting to Bitcoin network or Ethereum network, giving your computation power to have the network alive. Now, when these computing things are solving mathematical puzzle, it's using your computational power, right? So if it's using that, why will somebody do that without any incentive? So that fee is essentially the incentive to be as a miner on the blockchain. So that's why transactional fees are always there on blockchains. So even if I go back again, and if you see any transaction, if I go to transactions, let me see. Yeah. So if I go to these transactions, and if, oh, sorry. Yeah. So if you see, let me see if I have, yeah. One second. Just give me. Yeah. I'll share you one more tab. So that was Bengal blockchain. Bengal blockchain, we're not supposed to show transactions because those are crypto things in a government. But this is our network. Here, any transaction, right? Any transaction would have a value of the transaction. So this is not a tradable crypto. This is a permission network, so it's not a tradable crypto. But any transaction would use up this value, and it is given to the miner. So that's how incentives are given to all the validated nodes in any network. Okay. So I think I've done a lot of, okay, let me finish this and take a pause. So, or maybe this part, this one, and then, okay, let me go through this, a couple of slides more. Okay, what are fungible, non-fungible tokens? We've heard about NFTs, right? OpenSea and all these different companies have come up with NFTs. Art has a lot of NFTs. So what's a non-fungible token versus a fungible token? We've spoken about wallets. Inside wallets, you have tokens. So anybody who has to do a transaction needs money on the blockchain to do a transaction. It's not free of cost. You need money to do it. So these tokens are something like this. If I give you a 1 rupee coin, Indian 1 rupee coin, and I give you one more Indian 1 rupee coin, both are the same. You cannot distinguish one from the other. But if I give you a token which has a serial number and the other token which has a serial number with some properties, with some properties exclusive to that token, then it's a non-fungible token. So fungible means something which is replaceable with another token. So whether I give you that 1 rupee or another 1 rupee, it doesn't matter. But if I give you a special coin, it does matter because that coin has a higher value than the other token. So why is it used? It is used for asset tokenization. You can use it, fungible or non-fungible. So let's say I have a piece of art and I want to attach 10 or one non-fungible token to it. I can do that. And I can say that non-fungible token is in the wallet of Mr. X. So Mr. X is the owner of that piece of art. So that's how non-fungible tokens are used. Just gave you one example. So anything else, Bitcoin and Ethereum, all these are fungible tokens. But NFT is digital art, collectibles, game items, event tickets. anything can be represented as a non-fungible token, and it can have asset ownership. You can associate that to an asset ownership. And this is how even tokenization use cases, when we talk about it, we'll talk about how fungible tokens or non-fungible tokens are used in shared ownerships. I can have three tokens associated to a apartment in Kolkata. And if I own one out of those three, that means, and let's say I give equal weightage to all the three, so I own 33.33% of that apartment. So whatever rental income comes for that flat, I will get 1/3 of the rental income to my account. That's how shared ownership, fractional ownership can increase liquidity in the industry. So that's something where real world assets, tokenization use cases are very, very powerful, but it has to support with the law of the land. That's why it is taking more time for adoption, but it will eventually come up because it will bring in liquidity to various industries, especially real estate is absolutely looking at that. Now, blockchain data structure, again, I'll share this, but if you want to know, it's essentially what I showed you. There are multiple transactions in a block. There is something called a genesis block. So whenever we start a blockchain, there is a genesis block. And then that genesis block gives to a child block. So that child block's parent block is this. So when I was talking about the parent hash and block hash, so you have a block hash, you have a parent hash. So that's how you can connect back to your parent block. And that's how you create the entire blockchain. This is again a transactional flow. I have spoken about it. This is again the two keys I was talking about. You sign, Alice signs a transaction with a public key, private key. The public key is available to others to see that this uh, this message or this transaction was done by Alice, and it is available to through the public key. I know that this has been signed by this person. Proof of stake, proof of work, delegated proof of stake. Okay, I'll just take a pause here and then come to the consensus, because then I'll just finish the session after the questions, and maybe I'll talk about consensus while I'm answering the questions. If you have any questions, happy to answer them. I'll take also a moment here. Or if you want it in a different way, do let me know if this is not sounding okay. Are we good, or should we? I can take. I'll just complete the consensus if we are good, and then take a 10-minute break and then come back on maybe the blockchain and security part, if you don't have any questions.
Okay, so 10 minutes break, na? So we will again meet at 6:10.
Yeah. That would be good. I'll
Okay.
start off with consensus, and the next session would be blockchain security. I think this is what I'll start off with.
Okay.
Thanks. Just keep on mute. Should we start with
Yes,
the
yes, yes,
session?
yes.
Okay. Um, just give me 1 minute. Yeah. Okay. Where have we stopped? And I think one more important thing that we have to finish and then probably go into security is the consensus mechanisms. Whenever we talk about blockchain, consensus is a super important uh, decisioning point as well, because what kind of consensus would suit a particular use case is very important. So when we talk about Bitcoin, Bitcoin has always been on proof of work. So here what happens is, whoever is the first miner to solve uh, a certain puzzle, computational puzzle, depending on the complexity, wins, earns rewards, and also adds the block to the network. It's very secure, but at the same time, very energy intensive, because 51% consensus and all these things, it takes humongous computational power. So only certain use cases are good on Bitcoin. Now, if I come to what Ethereum did was, for business use cases where um, you have to do it faster. So there was something called a concept of staking. So any validator who's validating a transaction on the chain, uh, that validator has to stake a certain amount on the chain to solve the puzzle. Higher the stake, higher is your chance of validating that transaction. And not only that, whenever we want a faster transaction to happen on Ethereum, we have to give a higher gas fee to make it, because once you give a higher gas fee, so fee is paid by whom? If I am making a transaction on Ethereum, I will have to pay a fee. So that fee goes to the miner. So the higher the fee is, higher the chance of getting it validated faster. So that's how the economics work. So it's the token economy and all these tokenomics and these words you'll keep hearing a lot. So this is proof of stake. So there is, if you have a malicious behavior, you lose that stake that you've made, whatever stake you've made as a validator, you lose that if you are a malicious validator. But it is more energy efficient, because it's not the entire the network, it's not a high I mean, the entire 51% is not validating, so the network is smaller, validated network is smaller. Now, nominated proof of stake was even more efficient, because it took care of both things. One is efficiency, the security, the speed, as well as validating it with much more security. So proof of work was much more secure but slower. Proof of stake was faster, less secure, So the best of both world was through delegated proof of stake or nominated proof of stake. So what Polkadot did was something called a dual finality. So what it does is there is one consensus protocol running to give you an initial consensus of the transaction so that you can go ahead with your business application. But the finality, which is the final stage, I mean, there is a primary consensus done, and then there is a second time, there is another finality done. So that's from single finality, it is a dual finality. So what it does, it lets the business application run while it is doing the second deterministic finality. So that's how dual finality changed the game a little bit. So it became a two-stage transaction finalization process on the blockchain network. So this is another concept that came in with Polkadot. This is again something we've discussed, but here, when we say permissioned blockchain, public blockchain, what does it mean? So you have something called writing access, you have reading access. Who can participate in the network? If it is permissionless and public, then everyone can write, everyone can read. That is public and permissionless. If it is restricted, so writing access is everyone, reading access is restricted. In that case, it is private and permissionless. Because this is how you typically say how the network is implemented. So when we talk about a Bengal blockchain where not everybody can read the transaction or everyone can read the transaction, so that is called public permission. So your writing is restricted, but everyone can read the transaction. That's when it is public permissioned. And the other one is private and permissioned. So where it's both is restricted. So these are the terms that we use when implementing blockchains. Now, this is a typical flow how a Bitcoin blockchain works. Let's do this, and this is the final slide, where how does if Bob is paying to Alice, so Bob has to make a payment to Alice on Bitcoin. What happens? I am Bob, I have to pay to Alice. I need two pieces of information, my private key and her public key, because I am paying to somebody else's public key. So Alice's public key, I will scan the QR. I know this is my destination address. I will sign with my private key and send the token or Bitcoin to Alice. Once I do that, the app alerts the miners around the world to verify the transaction. It verifies the transactions, and not only that, all the transactions that are to be verified in that period gets combined into one block. Then the new block is verified by the miners again. And then that new block is added to the chain once it is verified. Once it is verified, it will take around 10 to 15 minutes for the transaction to complete. And Bob will see that the transaction has been finalized. So the token has been transferred from this person to Alice. And this is how a Bitcoin blockchain works. Finally, use cases, blockchain in the public sector, if we look at, central banking, CBDC is being implemented in India across and many other countries. Then validation of educational, professional qualifications. I mean, a lot of governments are using it. Tracking vaccinations, citizen documents, loans, student grants, Land titles, that's probably one of the leading examples here in India. A lot of land titles are being put on blockchain, as well as a lot of land documents are put on chain. So these are typical use cases. I will shift to the security now. I hope it's visible. Yes, it is. I can see. Now, if you have any questions, you can put it on the chat here because I'm starting off with security. So if there is none, then I'll start with this. Okay. So why so much of, I mean, today, because of the cybercrime and a lot of digital crimes that are happening, security is of essence, and most of it is, I mean, you'll hear a lot of cybersecurity discussions happening across the board, across various forums. Now, what did blockchain change? Now, since we had the first session, we spoke about centralized and decentralized. So blockchain changed the game fundamentally in two things. Who do we trust to store our data? Who do we trust to verify our transactions? And who do we trust when disputes happen? So if I have to bring in that trust in the system itself, that's what blockchain changed. It doesn't ask you to trust a single authority. It embeds trust directly inside the system itself. So that's how blockchain changed the game. The consensus and all we've already discussed. Let's go to what's the triad. Now, whenever we talk about security in digital systems, there are three things. One is confidentiality, like what is being shared, whether my data is confidential, the integrity of the data, which blockchain brings in by design, the availability of the data. Can I see my information when I need it? So if I go to more cybersecurity discussions, right? We speak a lot about confidentiality. Did someone steal the data or not? But blockchain is more on the integrity side of things. So it talks about whether the data was immutable and whether the data was changed or not. So can this data be changed without detection? It can definitely detect if there is a change in information. So that's what blockchain flipped. Instead of trusting the institution, we trust cryptography, the consensus, and it's through mathematical process you are able to trust that the data has not changed. And everyone can see the data. That's the transparency side. Okay. Now, how did blockchain come in as a security technology? So as a security technology, traditional security, we always talk about the perimeters, protecting a server, trusting the administrator. Blockchain shifts that trusting the authority to verifying through protocol. So through a protocol, I'm able to verify what is going to happen or the rules through smart contracts or the design of the chain itself. Integrity, it's no longer dependent on who controls the database. You're not dependent on the database administrator. It will run on its own. So the validation ensures that the data is correct. And any tampering becomes visible because it's not possible. First of all, mathematically not possible. Even if you tamper, it is visible. And the trail of information. So it's auditable, right? So whenever you're changing any information, it sees from what information it changed to another because it's an append-only database. So we spoke about append only. So this is where that thing comes up. And then if I go quickly into the data ownership side, which we have spoken in the last session, that is from centralized systems, which was when we spoke about centralized system, there was one owner, one failure point, one authority decides the truth, like banks, governments, large enterprises, these kind of. So a single authority owns, stores, controls, and manages all data. From there, we move to distributed systems where data is replicated across multiple servers or regions for resilience. There was it was more resilient, but still you had a lot of coordination problems because you are replicating the data into multiple places. Still centrally controlled. Infrastructure is more distributed. So it will be something like a AWS, right? Or Azure cloud system. So you have multiple regions where you can store the data or replicate the data. They're doing it by themselves also as a DR, DC, and all. So then comes the hybrid systems. Hybrid systems, partial decentralization is there, but still these intermediaries will be there. It's a combination of centralized governance with distributed infrastructure. That's multi-cloud deployments, or maybe a permissioned consortium network where you know who all are part of your consortium, but still it is essentially not completely decentralized. It is only decentralized between the members of the consortium. That's a hybrid system. So most of the enterprise applications we are looking at are hybrid systems, not completely put on blockchain. That's what we are seeing in the industry, even today, except a few use cases which are good for blockchain. And if I look at blockchain, it is completely more decentralized, but a secret about blockchain, right? Even Ethereum. The governance of the chain, when the fork will happen, when the new Ethereum 2 upgrade would happen, it is also decided by the Ethereum Foundation. It's not completely in the true sense decentralized. There is a foundation which decides it, like what all changes may happen to the chain in the future. The governance part is not yet decentralized. It is even, we shouldn't call it centralized because it's a foundation where there are multiple participants, and those participants also include a lot of industry bodies, even companies part of the Ethereum Foundation. But it's essentially more decentralized. Now, why we need blockchain? So again, coming to the same thing that we have been discussing, blockchain has emerged because we can now trust open networks. Earlier, open networks are very fragile, but now with mathematical, because we put the trust into a mathematical computation, so we can still work in an open network with certain amount of trust. In open peer-to-peer environments, if I look at, participants don't know each other. Some may fail technically, others may act maliciously. So these were the reasons why blockchain came into, even in a peer-to-peer, there were participants, who may act maliciously. So even that can be stopped through the consensus mechanism. So what blockchain solved through all this is, I think we have to talk about another very important thing here, which is the Byzantine's general problem. And you'll hear this. Whenever we go into any course of blockchain, so what is Byzantine's problem? General's problem. It was so there were a lot of actors who will agree upon. You have to agree upon how do you. So how do I explain that? So there are, how do you, sorry? Do we have a question?
So Nusisha, please mute your microphone.
Okay, so let me explain that. So how do distributed actors? So you have a lot of actors, a lot of participants in a network agree on one version of the truth despite bad actors. That's what Bitcoin and all these things that we discussed, we just found out, right? So that is the problem. So there are bad actors in an army. So that was the Byzantine general problem. But how do you know which is the version of the truth? So blockchain solved that problem in a untrusted environment, how systematically we are able to find out the truth. So that was the breakthrough. It was more reliable, it was more verifiable, uh, and that's why blockchain was required. These are things we've already discussed: hashing, public key, private key, cryptography, and consensus protocols. We've already gone through that. This is again, we have covered, but let's go through this. So what are the different layers? You have a cryptographic layer. On top of the cryptographic layer, there is a data layer. Uh, so if I look at what is the cryptographic layer? The cryptographic layer is where the math happens. All these puzzles we hear, right? Somebody is solving a puzzle. The compute power is solving a puzzle. That's where the cryptographic layer or the math is. The data layer is where the structure is. How are you storing the data inside the blockchain in terms of blocks and how different blocks are linked to each other. The network layer is the P2P protocol. This is the protocol layer. So there is a network, P2P protocol called libp2p. Libp2p is one of the protocols for Polkadot. So that's the protocol layer where I was talking about. A lot of engineers are working on that layer, and that's the most regarded people of blockchain is working on that layer. Network layer is because that's where propagation happens. All your ledger is propagated to multiple nodes. So that's network layer. That P2P layer is the holy grail. So that's where propagation is happening. Consensus layer is the different consensus protocols. Again, consensus protocols is also somewhere where these core engineers are working on. It's again another very, very critical layer. And finally, the applications. On top are all the applications where the business logic resides. So this is again something we have already covered, but what from centralized databases where it was owned and controlled by one entity to shared with intermediaries where you had federated databases to blockchain ledgers where it is replicated across all participants. So this is again, this we covered a bit what blockchain cannot magically solve. So you're hearing a lot about quantum, right? So quantum can actually break smaller networks very easily. So that's where the bigger the network, and both sides there is a lot of work going on. Like quantum resistant blockchain networks are now coming up. So it's not a silver bullet. However, it is much better than, and adoption is happening much more pragmatically now. There are use cases which are kind of established, and though all these things are there, you're still hearing a lot of privacy leakage happening because these are transparent ledgers. So if somebody puts PII information on the blockchain, nobody can delete it. That's the problem. Now, if you just put any data, it will not stop to put the data, right? If I put my phone number on just as it is without hashing on the Ethereum network, if somebody puts it, that's it. It's permissionless. It's available throughout life. So these are issues that are there. So how do you sort out these PII issues? So these are problems that we are facing more on the data side. TPDP Act is now pretty much active. And going ahead, what we are seeing is the identity market on the blockchain side is growing pretty big. The identity use cases are pretty well established other than payments and all. AI and blockchain fusion, like I said, it's growing at a 20 plus CAGR. So AI blockchain together is solving a lot of problems. And the risk that I was talking about, the quantum risk. So these are things that we can look in the future. That's about it. More on the technology aspect. Now I'll go into the live demo of SDC. I'll show you how a blockchain transaction happens. So it was a very short session, but I would really love to have a more interactive discussion now that I've covered a lot of things, and I would love to show you from the actual applications. So do let me know what kind of questions are coming to your mind. So here on, it will be more of demos and showing it on the applications itself. So I'll just take a pause for 2 minutes, and if you have any questions. Either it's very boring or it's pretty clear. I mean, I take it both ways.
Hello, good evening, sir.
Yeah.
Sir, I am
Please.
having one doubt regarding the transaction. Every minute there is a lot of transaction. How they will be stored? Huge data get accommodated in a very less time. Is there any option to store?
So your question is whose transaction is being taken into that block? Is that the question?
Yes, any transaction it can be shared to multiple parties in the group. If there are a lot of transaction happening within a second, then how they are stored, how they are maintained in the memory like that? I'm having questions.
Okay. So let me go to this. Okay. So this is a good question. Let me give you an example of Polkadot. So this is one of the. So there are multiple blockchains. Multiple blockchains work in different ways. Let's say I submit transaction, and not just me. There are multiple people submitting transactions, just like this one. Okay. There are. This is a registered DID. So what is it? I'll just go into this and show you. It's a transaction where I'm submitting UDIN numbers. It's not an actual UDIN, so because I had to show it in the demo, so I had to keep it masked. But this is a UDIN number from West Bengal. So there are some government document which has a public visibility. It's an agreement document, and there is a unique document identification number. So this was given by one application. Similarly, there were multiple such transactions put into the blockchain for it to get validated and put into a block. What happens is there is something called a block time. Now, let me show you one more thing. So I'm actually showing it from the system itself so that it's much more clear. So I'm sharing one more tab.
Okay, sir.
What
Okay.
you are seeing right now is a blockchain network which has 3 validators. It's just a test network. 3 validators with a public node and validator nodes. Every 5 seconds, there is a block created. If you see here, see every 5 seconds, you will see one more block getting created. Right? So what's really happening is in that 5 seconds, and there is a block size. So let's say the block size is 15 MB. Whatever transactions I can pack in that 15 MB, let's say 12 MB is for transaction, 3 MB is for the governance of the block. There are multiple things that you have to look into a block structure. Those transactions in a FIFO, I mean, whatever comes in first would be packed into the block and it would be submitted. There is one more concept called staking. If I stake a higher amount, that would be having a higher precedence over other transactions. So how is that done? Let's say I go to a Polygon transaction. And this is a Polygon transaction, okay? So if you look at the Polygon transaction, whenever you're making a transaction, there is a transaction value or transaction fee that I am paying. If I put a higher transaction fee, it will have a higher precedence. It will be mined earlier than a lower transaction fee amount. If I put a fee which is very low, it will not be mined at all. There's a minimum fee, and if you put a premium on it, it will get executed faster. That's how it is selected. There is a transaction fee which determines how fast it will be getting mined, and there is a block time on which during which it will be packed inside the block. Now, if I come back to what I was showing, if you go into this, you will see this block 951348 has all these transactions packed. It does not mean that only these 40 transactions were there in the queue. There could have been more transactions. Like if I go into this one, you'll see every moment there is a lot of transactions happening. This is where UDIN transactions happen, and this just went in at 6:43. So this is a live blockchain that is running. So every moment there's a huge amount of transactions happen. Okay. So this is how, did I answer your question?
Yes, sir. Yes, sir. I got it.
Yeah, sure.
Excellent answer.
Hello. Hello.
Yeah.
Sir, actually, my name is Partho Sarkar.
Yeah.
Actually, between blockchain technology and post-quantum cryptography, which one is chosen for the security purposes? Which one is best?
Again, it depends on the context. See, there is again, there is a there is
For
also,
the resource constant devices, okay, IoT devices actually.
okay, for IoT.
Yeah.
Again, there are currently it depends. Again, IoT. Whenever you're talking about IoT, how sensitive is it? So
Yeah.
it is a trade-off that we have to do
Yeah.
with cost, with the sensitivity of the data, with a lot of things. See, if I look at, yeah, definitely it makes sense. If I go for everything, whatever is more secure, more, it is a trade-off for time, speed, cost, a whole lot of things. There is no right answer to this. Now, if you're looking at a cheaper solution, and this is something we faced. We were doing something on, and I'll share this. We were doing something on honey traceability. So,
sir, actually, which one is energy efficient?
Energy efficient right now, if you, again, blockchain, when I was discussing those, right?
Okay.
The recent consensus mechanisms are less energy. I mean, they consume a lot less energy. It's more energy efficient. But quantum, again, it's not that energy efficient, but they are also working on it, right?
Okay.
So those are the considerations you just mentioned. Like those are the considerations we have to do. What makes sense from a cost standpoint, from an energy efficiency standpoint, from a time standpoint, from a speed standpoint. We were doing something like a smart hive. for traceability from hive to the bottle. Now, smart hive, you can do it with IoT sensors, but the cost of an IoT sensor at that point in time, about 4 or 5 years back, to monitor that hive was not enough. I mean, the unit economics was not working out, because from one hive you can probably get the amount of honey that you can get from that, and you can sell at whatever price. That was not matching up to the price I would spend on each IoT device for each hive. Then we spoke about LoRaWANs, and
Yeah.
I mean, that's a different discussion altogether. But that's what I wanted to say is, it's all about the trade-off and the use case itself. There's no one answer to it.
Okay. Thank you, sir. Thank you very much.
Thanks. What are the applications of blockchain in India? Okay. Lots. And that's where my next session would start. So we'll talk about supply chain. We'll talk about a very good use case, which is, I mean, if I go away from fintech, not fintech, that's also a fintech use case, but go away from payments, CBDC. CBDC is one of the larger use cases which is happening in India at a government level, at a national government level. Second is your warehouse receipts financing. It's a tokenized asset. So if I talk about that, we used to have doubles or the same receipt from a warehouse being financed multiple number of times. So if I tokenize that asset, if I've got a bill discounting from a particular receipt from one bank, it would be available to another bank. So you cannot discount the same bill multiple number of times. That was a fraud that used to happen in the warehouse receipts industry. So warehouse receipts financing was a very good use case from a blockchain standpoint, by tokenizing the receipts. That's a good use case. From a government standpoint, I'll anyway show how we are doing it in different state governments as well. Land titles, seed traceability is happening in Andhra. Spurious seeds, they want to reduce spurious seeds in the market. So that's more from a provenance standpoint or traceability standpoint. These are the use cases. Besides that, digital certificates, any kind of certificates. UDIN is one of the larger implementations in our state, where all types of documents that are issued by the government are given a UDIN number and also a blockchain identity, where it can be verified in real time, because the hash is kept on blockchain. So to give you one example, let's say there is an environmental clearance document. So, and that is let's say a 30 or a 40-page document. Earlier, it was issued by the Environment Department, and it will be verified whether you're following all the clauses in the municipality department when you're using the land. So earlier, the verification used to take a lot of time. Now, if I just give the UDIN number, it's just a click of a button to verify which is the original source of truth. So now the source of truth has become one, and multiple departments are able to share information amongst each other using a UDIN number. It's not only that, it is reducing your carbon footprint, because earlier the same document would be uploaded into multiple departments, multiple other departments. The same document would be, and you don't know whether a tampered document is uploaded or not. Today, all you have to do is just give the UDIN, provide the UDIN number to other departments, and they would verify it. So these are good use cases from the government side as well as from the private side. Asset tokenization, like one more very good use case that I'll talk about is in the real estate industry, on the asset tokenization as well as confidentiality, where blockchain and AI are working hand in hand. I'll talk about that in a moment. So if you're good with questions, then let me go into this part. and then show the applications as well side by side. So this is what we were just talking about. This is Udin. And so Udin is basically a document traceability and verification for West Bengal government. And any document, it can be any document from a department, if it's uploaded using a Udin number, and I'll show you a dummy, these are dummy transactions I'll have to show you, can't show you the actual one. But this is a Udin transaction. So this was a transaction made by somebody with an Aadhaar ending with this.
Are you sharing your screen? It's not visible. The Udin is not visible.
Oh, sorry. Yeah. Yeah. So this is the transaction. So this is a Udin transaction where I just came from here. So let me come back here. So if I take this transaction, it was a transaction made by this person. This was the public key. I spoke about public key, right? So this is the address of the person who did the transaction. It was a transaction made for some document which has a file content hash of this. So if I have to verify the hash of the document, I can always verify. And this is permanent on Bengal blockchain. 10 years later also, we know this is the document hash. So this is one of the use cases where continuously blockchain transactions are being made and Udin transactions are being submitted by the state. See, every second you will see, so millions of transactions are going to happen on this, on the Udin network. So this is a Udin transaction. So that's one of the use cases. The second, I'll come to, and here let's make it more interactive. If you have any questions on the use case, let me know. Just speak out because I'm not able to see who's putting it on the chat. So this is again another thing on the Bengal blockchain. It's a low-code blockchain SaaS. So these are things that how blockchains have developed. So it's an underlying network. You don't need to understand how a blockchain works. If you have any thing that you want to put it on the blockchain explorer or on Bengal blockchain or any other these purpose-built chains. So Polkadot, this is BWS own blockchain. We don't use anybody else's blockchain, so it's our own chain, and we are it's a purpose-built chain for government applications as well as supply chain applications. So here we have a low code where you can submit transactions on the blockchain in real time. So what would happen is, say, I'll just show you how a blockchain transaction really occurs on a low-code platform. See, here I'm submitting a transaction to a blockchain, and it's a low-code platform where I'm submitting name, ID, date, and just imagine that there is no PII here. It's just a transaction just to show. Let's say ABC is the name, identity is ID 123, date you give some date, 2026, and you want to upload a file. So let's say you upload this file It's a public, so you can make it private or you can make it. So this is where confidentiality comes in. If you want to make it confidential, you make it private. Not everybody would be able to see it. Only people I give access to would be able to see this data. So if I make the ID private, you will not see that on the public chain, on the public explorer. Now I submit this data. Oh, sorry. Test 777. And I submit this DID. So what it will create is it will create a identity. It is submitting a transaction now to the blockchain. Now, if there are multiple transactions that are going on now, it will take some time because now it's on the public chain, so it will take some time. It's still going on. Yes, I think it has completed. So this is the DID transaction. See, test 777. But this is from your web platform. Now, if I have to look into it into my blockchain system, see, I've just shared it. We just created this name ABC. You will not see the identity because that's not made public. You see the date of birth. It's February 1st. You see the name and you see the file that has been hashed. So you don't see the actual file. Now, every time I hash this file, I hash the original file that I've hashed, it will always be matching this. And who submitted the transaction? This is this is the identity of this transaction. So it's an identity blockchain. So it created an identity for the transaction that I've done. So this is what I was talking about, and this is one of the applications that we can, and this leads us to multiple applications on a statewide blockchain. It is not just one department. Any department tomorrow can have, and they can go live in a matter of a day. That's the speed that we can go live at. So all you have to do is just write a REST API. If we give you access to that license, and if you have enough funds in your balance, you would be able to write that transaction in. So it's a permission network, so we'll have to onboard you with a identity. So that's how it is working here in Bengal blockchain or even in any other identity chains. This is one of the use cases that we did for the United Nations. This was a coffee traceability. Maybe we can share the video as well. How so Devopriya, if you can, since you're there is part of the call, if you can start or share in the chat the video of the coffee traceability.
Yeah, one moment.
So this is what it is. So now you'll see something, not identity, but it's a chain of custody. So the entire coffee procurement, right from farmers, when it happened, who collected it, who attested it, to the coffee being received in Uganda at Masha Coffee, sorting, when it was done, at what temperature, drying, all these things are captured till packaging. So it's the entire journey of the coffee. They are now getting almost 15% premium on the coffee. So that's another use case that we've done. I'll show you one more here. It is a honey traceability, where the entire honey test report, which was done at ICAR CISH Malda, the test report is also on chain. So nutritional parameters of that batch of honey. So any batch, any bottle that you take from that, from that batch, you get the entire traceability of the test data of that batch. So it has minerals, what kind of minerals it has. So it has all the. So this is a use case more on the agri side, the food systems side, where you can provide traceability across the supply chain or across the movement of goods across the supply chain. This is one. This is the one I was talking about. Sorry, I think I did not share the honey. Sorry, without sharing, I showed. But this is the one I was talking about for a honey brand. Here we also store the test report, which is this on the blockchain. So you're able to see the nutritional parameters, the minerals, so the lab assistant who tested it, even their identity is captured. That's how we build traceability on chain. So while you're doing it on your normal ERP systems, on the back end, it is collecting all this information. So if I go and see it, I'll see that it was done at this facility. So this is another use case for product traceability.
I've shared the YouTube link in the chat.
Yeah, sure. So this is a just wanted to share you this so that you get like how a real world application is being put on blockchain.
I think there is no sound. I'm not sure if others can hear.
There is no sound coming out.
No, I can't hear. Can others hear?
Yeah, there is no sound. Yes, there is no sound.
Oh, okay. Okay. I think we have shared the link. Somebody can go through the link instead of, I don't know why the sound is not coming. I have shared. I don't know. I'm able to hear, but I'm not sure. Like maybe some issues. Okay, we've shared the link. You can go through it at any point in time. But what it talks about is, I'll just go through it. So it talks about is the entire supply chain. There are a lot of points that we are capturing information. And it's not just blockchain. There are certain AI components being also used to identify or improve efficiencies in the supply chain. So, and it has increased their profitability. Not only that, they have better visibility into their own inventories. Old stock is being cleared much faster. So there are tagging done on the stock level as well. So it's a pretty large initiative which we started by UNDP, but then we took over. The brand is now earning a premium on more traceable coffee. This is another very good use case where we did this for a property management company in UAE. So there in the Middle East, what was happening is, and the whole conversation started like this. So there are Bollywood celebrities, pretty high net worth people who buy a lot of properties there with their golden visa and all these things. And not only that, there are VVIPs from around the world who come to Dubai and they buy pretty posh apartments and all, and houses and villas and all. But whenever there is a house sale which is happening in the Middle East, they give something called a sales purchase agreement. And the property management company would store that on Salesforce. After it stores that, it has to share it with multiple parties. So after you buy an apartment, maybe the cooling solutions company, let's say who's going to do the central air conditioning, you have to share the dimensions of the apartment. So typically what used to happen is they will share the entire sales purchase agreement, and the sales purchase agreement would have a lot of PII information about a certain individual who's a VVIP. So what it raised was a lot of concerns about their private information like phone number and all going out to multiple companies. And that's where they wanted something like one is storing it on the chain, but the second part was, how do I anonymize certain data using AI? So this is where AI and blockchain work together. So we were anonymizing certain data on the fly, understanding that this is a SPII or a PII, or understanding contextually that this is giving out information about the location, and masking that out from documents which were shared with anybody outside. So if a bank is taking that information, it makes sense. If the municipality is taking that information, we have to share those information. But if a private company like a cooling solutions company is taking, it will mask all the PIIs and then share. This was another use case where AI and blockchain work together, and this was for Aldar properties, where both these things are working together, and that's another use case. Now, another is DMRVs. Now we talk about a lot of these carbon credit, greening solutions, climate solutions and all. Where blockchain can play a role is giving a trail of information that is verified, auditable for activities that are happening on the supply chain.
Ayon, are you sharing a screen?
Yes.
It's not showing.
It's not showing. When did it?
I think since the last slide you were talking about, since then.
Oh, from this slide?
Yes.
Yeah. So this is the slide where I just spoke about, where it is a real estate document security leveraging AI and blockchain. If you have any questions, I can answer. But this is essentially which I spoke about. This is for a property management company where we are anonymizing certain portions of the sales purchase agreement. If this is the sales purchase agreement, as part of the PII is being anonymized, but the entire information is being stored on the chain. The land title or the sales SPA is being stored on the chain. Now coming to climate applications on blockchain, carbon credit tokenization and all. Apart from the carbon credits which are getting tokenized, there are a lot of activities which lead to carbon sequestration or calculating the carbon credits, right? So all these activities can be stored as units of information on the blockchain, and all this information are trusted source of data. So with all this trusted source of data, we can generate carbon credits, carbon credit information, and that can be stored on an immutable ledger like blockchain. And even the carbon credits itself can be tokenized, and that can exchange hands from one person to other person. And here, since I'm talking about tokenization, comes the the use case that I was talking about. It can be for real estate, it can be for any asset. So if I have my products, or let's say I have kept potatoes on the cold storage of a warehouse, I receive a digital warehouse certificate. The lender of the bank gives me a loan based on that receipt, which is called a warehouse receipt. If I keep it on the blockchain, it is visible to other banks. Not only that, I will not be able to discount it multiple number of times. And if it is digitalized through a smart contract, it will automatically give me or determine what is the amount of loan I can expect out of that collateral. So collateralized receipts, real-time auditing, tracking can be done. It's a very good use case of blockchain, and it's being done in Maharashtra and in the western side as well by 2-3 companies. There's one very big company who's doing it on the agri side, which is Arya. Arya AG is doing a lot of these use cases. Whirl is doing it. So Whirl is no more called Whirl. The company name has changed, but so that is another company. And the same thing for on the real estate side. So real estate side, if there is a big real estate and you have multiple investors in that real estate, the smart contract can determine how much rental income is coming, and the rental income can be distributed in the percentage that we all have invested our tokens in. So let's say there are 3 people and somebody has invested 50%, someone has invested 30, and someone has invested 20. So let's say I have 2 tokens, somebody else has 3 tokens, someone else has 5 tokens. When the rental income comes, 50% will automatically be in the order of distribution, it will automatically get distributed. That's how it can work systematically through smart contracts. Another very good example from the logistics world is the bill of lading. Bill of lading is getting checked from the origin port and the destination port, right? So those are 2 geographically disparate places. So that bill of lading can be tokenized also. It is also another collateralized form of financing that can happen on the bill of lading. So, and not only that, the verification of the bill of lading can be done on the chain. So this is about it. Like these are the various use cases on the real world assets, which I was saying, it's becoming, a lot of work is happening here. Fractionalization, I've already spoken about, like you can own an asset as a fraction. One second. So that's one of the use cases. The global use cases that are already there, BlackRock has a fund which is now on Ethereum. It's a tokenized money market fund. Tether Gold, like I said, it's a gold-backed token. Just like Tether was initially backed on the dollar, there's a XAUT which is backed on gold. Fine arts and collectibles, there are lots like whiskeys from distilleries, and depending on which barrel. So a lot of ownership. So again, coming back to where I started, ownership, integrity. These are the key words which blockchain proves. It ensures integrity, it proves ownership. So these are the key things in the chain. This is our team, if that makes sense. Do I have to talk briefly about certain people? So Vijay comes from the core Ethereum background. He was one of the core guys in the Ethereum team who has built our chain. And this is one of our team members. So he's based out of Canada. He's based from, I mean, he was initially part of the core Ethereum team and built one of the token standards. That's why he's built the chain all by himself. So that's about it. Happy to answer any questions. Anything else you wish to see? It would be good to have questions in the final 5 minutes or 10 minutes if you wish. I would love to show it from the application itself. One of the things that I probably can mention here is whatever identities that I showed you, there is something called a decentralized identifier. It's a standard for W3C. So that's also something where things are heading. So a lot of sovereign identities, decentralized identifiers, these are standards that are developing and it's being implemented on the blockchain. So Bengal blockchain has actually DID's version 1.2 implemented on the blockchain itself. It's a W3C standard. Okay. Any questions? So are we
I
good?
think there is no question. I think so. There is no question. So
No, it was good
if you have a
discussing.
question, you can raise your hands. Yeah, you can raise your hand.
Or write it on the chat if you have any.
Yes, 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 yes. So I think there is no question. So we can now conclude the session. No?
Yeah, thank you. Thank you all for listening in. Hope it was useful. If you have anything, you can reach out if you want to on this one. So this is where most of our team members would definitely one of our team members would respond to if there are anything on the blockchain side. If you have any questions, happy to answer them.
So thank you very much, Ayon. So
Thanks,
today's
Mr.
lecture, yeah, today's lecture has not only strengthened our conceptual understanding, but has also encouraged us to explore the practical and research-oriented dimension of this emerging technology. Okay, so I sincerely thank our distinguished speaker, Ayon Hazra, for sharing these valuable insights and engaging us the both theoretical foundation as well as the practical also real world perspectives. I also thank all the participants for their attentive presence and active interest. So with this, now we can conclude the session of our online lecture series. This is the first lecture. So next day, that is tomorrow, the same time we will again meet. So thank you all for joining us. Thank you.
Thank you.